So welcome everyone to the Node.js and Oracle Database Office Hours for February. We didn't have one back in January. It was too near the sort of big festive season, and for me here in Australia, it was summer holidays. So it was not a good time to be working, but we did actually do a lot of work, especially over the vacation, and we'll talk a little bit about that coming up. So we have, I think, three of us here on the line. So Dan McGann is obviously the expert here in JavaScript at Oracle. If you followed any of the forums. Anthony Tuininga is the sort of powerhouse behind some of the development for the driver and other drivers. Myself, sort of product manager, doing some of the legwork in the back end. And Blaine, who's not with us today, is an evangelist who does, again, sort of conferences, et cetera, et cetera. Those are Twitter handles. So the office hours general theme is that this is a sort of ask any session, and you can ask us any questions at any time, but we'll probably just run through a few slides. We will run through a few slides and then throw the mic over to you. I actually have just a couple of quick slides. I thought it was about time we have a stack view refresher, just so I can kind of explain what's going on here in the Oracle world for people who don't kind of know how this all fits together in the driver landscape. And obviously on the right-hand side, we have the Oracle database. The other big component, which I'll come back to a little bit, is the Oracle network layer, the network services, or sometimes known as SQLnet. And Oracle client libraries are talking across that, talking down to the Oracle network layer into the database and backwards. And these are all pre-built binaries, proprietary software, thick client installs, and people often don't like some of that. But these two combined, and obviously the database, have a lot of technology in them. They have all of the caching, security, etc. So we have this architecture for a reason, that we can reuse this stack in a number of places. It's tried, true, tested, has a lot of functionality. The bit which is different for some of our open source drivers is that we have this layer called ODPI-C, which is just a C wrapper around a lower C interface. And this is actually common now. We use this for the Python driver. We use this for Node-oracledb. It gets used by some third-party drivers, such as the new Julia driver, oracle.jl. There are Rust drivers, etc., out there, which are now based on this. The Go language is another common one. On top of this, we have Node-oracledb proper. So this is the stack that we actually write here in this, this sort of product group. And another way of looking at this, by the way, is just to think about the ORA messages. So if you see an ORA prefix to an ORA message, it's probably coming from one of these two sides, the stacks, the Oracle client or the Oracle database sides. If you see something which has a TNS prefix, it's probably coming from the network layer. So it's something to do with your network protocols. You can't connect to the machine, or you've tried to connect to a database which isn't running or something like that. If you see something with a DPI prefix, it's going to be coming from this layer. And if you see something with an NJS, Node.js prefix, it's going to be coming from this layer. So that's just one of the sort of little quirky things which you can think about. But one of the reasons I wanted to speak about this is because you sometimes see us mention in things like the change logs for the driver, that a fix was an ODPI fix. And that really means that it's something which we fixed in that C wrapper layer, and Node-oracledb didn't actually need any particular code changes. It just got a feature for free, perhaps as a bug fix commonly. The other thing about this, just to wrap up here, is that this layer, the network layer, actually has a lot of functionality in terms of security. So this is where you do your encryption. This is where you do your load balancing, your service requests. So you can have events coming across from the database to say, or if you have multiple databases on say a rack cluster, events coming back to say which one has the least load, so that the client libraries know where to connect. It has load rate limiting to avoid connection storms. It has buffer sizes and things like that. So, there's a lot of configuration which is not going to be shown in the Node-oracledb documentation, because there's actually configuration here at this network layer. So just, a couple of thoughts there about how the stack works, just so you're kind of empowered to go and make changes and read the appropriate manuals. Okay, so we had last couple of weeks, we had the Node-oracledb 3.1 release out, and I thought we would just talk a little bit about some of the features there which were new in that. There's a whole bunch of major features. Bundled binaries, I will talk a little bit about. Deferred client loading, we talked about last time in December, so you can go back and look at the the recording for that if you want. And then I'm going to talk about the couple of the connection pool changes, the tagging and the callbacks. I'm not going to talk about the bottom one, removing a connection from the pool. That's just an extra option when you do a connection.close to say drop a connection from the pool. And as you can imagine, it kind of closes all the whole connection out. And that connection will then, well, not exist, but a new connection will get recreated when the pool has to grow again. That could be useful just in some cases if you have a connection which you think is not behaving well, or you've done something on it that you don't want to be shared. Maybe you set some connection state, which I'll talk about in a little bit later. Bundled binaries. So I just have one quick slide on that. So we did a change in the install process for Node-Oracle 3.1. And now when you do an install, you will get all of those binaries as you see there installed. Previously, we only installed one, and we had a kind of bootstrap process. So we had a two-stage install process. The initial install would install the JavaScript library layer, and then that would run, and then as part of your install, you wouldn't notice this, but the bootstrap would run and it would download one of these particular pre-built binaries. And that was space efficient, but it did cause some problems to some people. You needed that extra network access. It went to GitHub instead of the npm registry. Space-time trade-offs, space pain trade-offs. So what we've done now in 3.1 is we've said, okay, the space isn't too big. It's only a couple of megabytes. We're going to put all of these binaries in that npm package, which you're downloading from the npm registry, and you're going to get all of these on disk at one time when you do the install, and it's going to sit there. And then at runtime, when Node-oracledb fires, when you do that, require, the driver, the JavaScript layer for the driver will determine which one of these to load. And if it can't load it, then out of luck, you may be on one of the platforms we don't have binaries for AIX, for example, and you're going to have to go and compile from source code as you did in the previous versions. But if you have any of these three platforms, Mac, Linux, or Windows, or 64-bit, and you're running, this is the ABI, the Application Binary Interface, which is a Node.js feature. So this corresponds to Node 6, Node 8, Node 10, and then Node 11. If you're running on one of those, then everything will just work. You won't notice any difference. The good thing about this is that if you copy this directory, the OracleDB, let me go back. You copy the OracleDB directory around, Node modules OracleDB directory around between machines, or if you're running it, say, in VirtualBox on a shared disk, you're accessing it from Mac on one side and Linux on the other. Because the correct binary is chosen at runtime, it will just work. You won't need to do any kind of reinstall. So you've got a little bit more scope to share that around and do some pre-packaging if you have some kind of pre-packaging step and you're shipping this whole OracleDB directory around. Obviously, when Node 12 comes along, there's no binary there, so there'll be some issues, but we'll at some stage push out a new OracleDB release with that, or you're going to have to build from source code. But for the moment, install should be simpler, and then deployment is going to be a little bit better for some classes of application. Connection pooling. So we've often always recommended to use connection pooling when you have a lot of connections that are needed for short periods of time. Get connection, do some work, put it back in the pool so somebody else can pull it out and use it. It's also useful if you have a small number of connections, for example, one connection that is often idle. So it does some kind of database work and it just sits there maybe waiting for some user input. And what we would recommend in that case is use a connection pool, size 1, and when that application is idle, you would close the connection, so you'd put it back into the connection pool. And then when it wants to do some work, database work, it would get connection from the pool again. And the advantages of that are that the connection pool can do things like the load balancing. It can do better detection if the network has dropped out and the connection has become unusable. So you get better resiliency if you do that. Okay, session state. So pretty much every application sets connection state, session state, and in all practical senses, a session is the same as a connection. So don't get confused if I use those two words, just think connection whenever I say session. A lot of people do alter session commands date formats or time zones. Node actually with date formats and time zones, you could set those by environment variables, which may be the most efficient way, but sometimes it's easier operationally to do them in SQL at runtime. With pooled connections, any of that state or package state, session state is going to be retained in the connection when it's back in the pool, idle, waiting to be reused. And the next user of that connection is going to get that same state. And that's kind of good and bad. You know, it's just the way Oracle works. It's always worked that way. It's efficient because that state is retained. However, up until 3.1, you couldn't guarantee you're going to get a connection back which had that session state. And so you would actually have to do your alter session commands every time you did a get connection call, just in case you had a new connection which hadn't been used before, you know, the pool had grown or something had dropped and been recreated. We now in 3.1 have a session callback as part of connection pool creation, which is set as part of connection pool creation, which is much more efficient. So I've kind of divided this this set of slides up into kind of use case scenarios rather than just speaking about particular features. Once you understand the scenarios, then you can actually use the features in any other ways that you can think about. In the middle, you can see that we have this new session callback attribute as part of the create pool options. And we just set it to our method name, in this case, init session. So I would use this scenario when all connections should have the same state. So every application user wants, in this case, to be running in UTC time zone. Fairly simple, fairly straightforward. You do a get connection. This get connection is going to pull a connection from the pool, and the very first time it does that connection may need to be created, or it may be brand newly created, and never used before. It has no session state in it. And what's going to happen is that the init session will be called before get connection returns. And so this gets called. We obviously set this any state we want. Need to do the callback as the last thing so that we don't have any synchronization issues. And then get connection returns. And at the moment, this has UTC time zone in the session. The second time somebody does a get connection and happens to reuse that same connection in the pool, sorry, I don't have graphics for this yet. If a connection gets reused, it's in the pool, it's available for reuse. If that connection gets reused, it's not brand new, and then there's no need to call init session. But we just return immediately to the user. We haven't called init session by definition because of our application code up here. We know that this is going to be running in UTC all the time, whether or not it's called this function the very first time the connection was used, or didn't need to call it when that connection was reused. Is that clear enough? Do I need to go over that hand wave a bit more, Dan, Anthony?
Well, maybe. I think a lot of our examples for this particular feature are based on time zone, which is it's a good simple example, but we should probably say that we actually have a more efficient way to set time zone, right?
Yeah, that was the environment variable in general.
Yeah.
So if you have a microservice where you're calling the microservice 1,000 times, with Node-oracledb 3.0, you're going to need to be setting that session state each of those 1,000 calls. So you're going to end up with 2,000 executions. Node-oracledb 3.1, you only need to do that all the session once per connection in the pool. And once when it's brand new. If it gets reused, you never need to do that all the session again. So you're going to end up with much fewer executions. The application is going to be a lot more efficient. Okay, so that was end of scenario one. For connection tagging, you might use this when connections need differing state. So when somebody needs UTC and somebody needs Australia, Melbourne early morning time when you're still asleep like me, you might want to set sessions with a particular state and then try and request those sessions back again later to get the same session with that same state, so you don't need to do that session fix up again. We have this new attribute tag for the get connection call, and these have a semi-arbitrary syntax. Effectively, it's sort of A equals B, semicolon, C equals D syntax that you will want to be using. And what happens is very similar to the scenario one. If you get a new session or there's a connection in the connection pool which has been tagged by somebody else, we don't care about that, in the middle of running, and that connection has a particular tag, then when connection in the connection pool is selected for use, if it has a matching tag, we don't need to call this init session. If it doesn't have a matching tag, if there wasn't one available with a matching tag, if there was a brand new connection or connection pool was fully in use, had been fully sized, and didn't have anything with a matching connection, matching tag available, then init session would be called. And you get effectively to see what tag we wanted, user wanted, what tag the connection actually has. You can do some parsing on this to work out the various properties which were set on that connection tag, execute whatever statements to actually set your connection state. And then at the very end, we have to actually set that tag on the connection to indicate the matching state. So this is a semi-arbitrary tag. We get to choose the values, the A equals B kinds of values, but you want to be choosing those so it actually maps down to what you're setting here. And typically in the common examples, this line would actually be setting it exactly to the requested tag. Because by definition, I wanted a particular tag. I've changed my session to be equivalent to that tag, and then now I set the connection tag to be that. Remembering again, this is only called if connection tag requested is not the same as the connection tag that the connection actually has. In many cases, you'll find connection tag is empty. You get a sort of brand new session created. There is an extra option which sometimes if you use in your call, you may actually end up then seeing with other tags. Okay, to avoid losing it, let's go on to scenario 3. So this is actually a kind of like, you could use this for 1 and 2 as well, but I'm calling it a separate scenario. So if you're using database resident connection pooling, so that's a pool of connections on the database side, and you would be using that with a session pool, the connection pool in the Node-oracledb side as well. You can, and you're using Oracle 12.2 or later, you can actually, instead of having a Node callback, you can have a PL/SQL callback. And you have to set it, subtly the difference is you have to put it in quotes, so it's a string rather than just a Node.js method name. It has a particular declaration, the name doesn't matter, you call it whatever you like, put it in a package or not. But it takes these two parameters, requested tag and the actual tag. And then very similar to we saw in the Node.js example, you need some PL/SQL code to parse those two, requested and actual, and set the state. The big advantage when using database resident connection pooling is that this PL/SQL procedure is invoked on the database side. So there's no round trip between Node.js and the database to actually invoke the PL/SQL callback. And so as we saw before, round trips impact scalability, so reducing them is great. You can actually use it if you're not using DRCP, you can use a PL/SQL callback, and then it's going to need one round trip from Node.js to the database. But that may still be better than a badly coded Node.js method, which if you're doing lots of SQL statements, could be a lot of round trips backwards and forwards. That was it. That was the major new feature I just wanted to cover, the tagging connection pooling fix-up. It is now over to you to ask questions. There's only one person on the line at the moment. If you want to ask, go ahead and ask. Otherwise, we can wrap up and put the recording out for everybody to listen to.
Chris, I was always curious.
No questions. Thanks, Matt. That's great.
I don't know if we have the answer to this, but if the max size of the connection pool is, let's say, 4, and I'm using tagging and I request a connection that doesn't have a tag, do we exceed the maximum of connections to create the new one, or how does that work?
So that works in where are we going? Scenario 2. That works because what happens is an existing connection in the pool is chosen. It doesn't have, the pool is maxed out, but somebody wants to do some work. So connection pool chooses one of those connections, clears the session information, clears the tags, and gives it back to us. So it has to does some work there in the back end.
Okay, got it. And do you happen to know offhand why the round trip, why DRCP gets the advantage of the round trip elimination with the PL SQL callback?
Yeah, the invocation of the callback is handled by the connection pool in the database by DRCP itself. So the pool is being managed in the database at that end. And since it's already in the database, it doesn't need to do any round trips to actually call PL SQL. Whereas in the Node.js case, the pool management is being done in the connection pool in Node.js itself.
Gotcha. Makes sense.
Well, thanks everyone for attending this office hours. We look forward to seeing you next month. Thanks to Dan and Anthony for attending as well. And let us know how you're going with Node.js and Oracle Database.
Thanks, everyone.
Yep, see ya.
Bye-bye.